We are live. Welcome to episode 11 of Tacit Talk. I am your host, Conor, and today with us I have a special guest who goes by Dzaima. And you might know Dzaima for any one of his many projects. Most recently, he is probably most well known for being the primary developer of the CBQN interpreter, which is the main interpreter that most folks that are playing around with BQN use these days. And on top of that, before CBQN, he also worked on BQN, dzaima BQN, which I believe was an implementation in Java, whereas CBQN is obviously in C. And before that, he also had dzaima APL, which was an APL written in Java. Welcome to Tacit Talk, Dzaima.
Hello.
How are you doing, and how are you enjoying the Advent of Code, the season of Advent of Code for 2024? I know you are at the top of the leaderboard, and I think also you were on the top 100 for both day 1 and I think it was day 12. And link in the show notes. We'll add a link to, you have a new YouTube channel, and I'm not sure if it's always been there, but you posted 2 different videos. I think the first one was like 2 minutes or something for day 1, and the second one was, I think, 8 minutes for day 12. It was thanks to Marshall on the most recent recording of Arraycast where he pointed that out. How you been enjoying it, and how are you so fast?
So day 1, I don't know how that happened. Yes, it's 2 minutes. Unfortunately, for a bunch of the days, I did not manage to be so fast.
Well,
but, besides day 12, I do have 2 other days where I was in the top 100, but I didn't make videos of those because I didn't feel like that there was much to be had in a 30-minute video.
Wow. So day 14, day 15 on top of days 12 and day 1. And
yeah,
it is pretty phenomenal. We'll probably talk about Advent of Code. I mean, in years past, have you been on the top, or is this like an outstanding year in terms of being able to make? Because these days there are tens of thousands, if not hundreds of thousands of folks that do Advent of Code. So it is extremely competitive, and you're competing with like competitive programmers that do things like, LeetCode and the ACM ICPC contest. And those folks, they're able to solve problems once they understand it in like 20 seconds. So it's incredibly difficult. Yeah, almost 250,000 people for at least part A, if I'm reading that correctly, on day 1.
and that's both parts.
Or both parts. Okay, yeah.
Yeah. So like on 2018, I did have a couple times on the top 100, but besides that, I don't think another year I bothered actually waking up at 7 a.m. for it, which is like the main restriction for me.
Oh, yeah.
But somehow on this year, I managed to coincidentally roll my sleep schedule around so that I can actually wake up at 7 a.m. And so, the places happened.
Yeah, it's pretty amazing. Pretty amazing, especially for day 12. I've seen both of your videos, and I mean, I guess what do you call them? The array languages and their tercity help, but the fact that you have some of the primitives and the techniques that you use, I guess we'll hop into that later, but it is quite impressive how you've been able to solve these so quickly. So I will mention for the viewers that are watching this currently on Friday morning, or depending on where you are in the world, it could be afternoon or evening. We are live, so we do have a chat section, which we're both monitoring. So if folks have questions for Dzaima throughout the episode, feel free to ask them. And if you're listening to this on YouTube, on an audio podcast, you can come back and I guess check the live stream recording later. Chris in the chat is asking if it's possible to make the font size slightly smaller, or slightly larger. I can make it out fine, but maybe if we start looking at code, we'll do a Control-Shift+. But yeah, let's hop back to sort of your origin story before we start talking about dzaima APL and dzaima BQN and CBQN. And maybe you can tell us about your introduction to computer science and software, programming, and then how you got into, the programming side of things, and then how you discovered array languages, and all the way to, implementing, what is it, 2 or 3 different, maybe there's even more that I'm not aware of, array languages. So throw it back to whenever you want to take it back to, sort of the origin stories of your computing background.
So at the age of 8, I believe, my mom taught me a bit of what PHP, HTML, etc. And at that time is when I came up with the name Dzaima, which is the first 2 letters of my real name and some garbage following it that sounded roughly coherent.
Interesting.
And somehow that's managed to stick around. After that, I have this memory of me being into programming for like the entire span of time after that, but the only record I can really find is at 2014 when a friend got me into, not a friend, an acquaintance, a family, some distant family member got me into Scratch. So then I was in playing around with Scratch for a while. At some point in parallel to that, I guess I got a bit into Minecraft Pocket Edition modding.
Okay. Minecraft programming is I think some people refer to it as.
The Pocket Edition, though, at those times it was in JavaScript, I believe.
Oh, wow.
So from that, at some point I found out about processing from, what's his name, Daniel Schiffman on YouTube. Those videos, he had a bunch of cool videos. So that's how I got into Java, which you can still see in dzaima/APL and BQN. Let's see. So that's processing, Scratch. From Scratch, I managed to get into CodeGolf Stack Exchange through the programming language, which with it being not suitably named for the audience of Scratch, was there called Bran Flakes.
Bran
so there was like
Flakes?
Bran Flakes.
And this was a code golfing language, or?
No, this is a super popular deep Turing Target language.
Okay.
That's how it was called there, because the actual name contains a swear word, and that was not acceptable in Scratch for obvious reasons.
I see.
So that was somehow tied into CodeGolf Stack Exchange, and into there I made a golfing language and participated in there for a while. Somehow found APL, opened the dialog APL book, whatever it's called, saw the first line of what 1 + 2, 3, 4, and that worked. Added to the array element wise, thought that was absolutely wonderful, and got stuck into APL from there.
Wow. So I think this is similar to a couple of folks' stories, is you basically discovered the array languages through code golfing and Stack Exchange. And
yeah,
that was your first exposure. You said you saw, was it the Mastering Dialog APL book? Or
Yep.
Yeah.
Yep.
So I think there's actually a refurbished version of that that's been published over the last year or two. And then fell in love with APL. So did you immediately go, because I guess, did the code golfing language that you wrote for your initial code golfing, does that still exist? Does that have a name, or was that kind of lost in the annals of time?
It still exists. Let's see. SOGL. That's what it's named.
And I'm assuming this was implemented in Java, because that was your language of choice at the time.
Yep. Indeed, it's implemented in Java. I didn't know how to Git at this point in time, so I just have multiple folders of versions. So, okay, no, more precisely, it's implemented in processing, which is essentially Java, but not quite. So,
Okay.
and then there's an online interpreter because that's kind of essential for participation in Code Golf Stack Exchange. I have no clue how to. Oh, cool. 2 plus does output 4. So there you go. There's some SOGL SOGL.
And is this array inspired at all, or was this purely
No, this
driven?
is before. This is before I knew about APL.
Okay. And what would you say it's closest to? Is it inspired by anything, or it was just what you
It's
thought
just
would get closest to
it's just
solving code golf?
it's a stack-based language.
Okay, a stack-based
So
language.
uh, otherwise, I think I just took from whatever other code golfing languages are common
Okay. Was this
back at the
when you did
time.
this? Was this at the time of? I know Vixel is a bit newer. That was from an
That's a lot newer.
yeah. Was Jelly
Yeah,
out at the time, or was this pre-Jelly even?
yeah. This was around the time of Jelly and Osabi 05AB1E.
Oh, interesting. I haven't. I'll have to look that up afterwards. I haven't heard of that code golfing language.
Yeah,
Okay.
that was like one of the two top ones. So I made this primarily for ASCII art. Somewhere around the time of finding APL, I got another code golfing language called Canvas. Nope, that's the wrong link. Nope, that's still the wrong link. Where is, well, I have to manually type it in. Yeah, there we go. 2 plus. Basically the same thing, except any ASCII is a string of itself. So a hello world is literally hello world.
Okay.
So this is sometime around me having discovered the APL. It's still not particularly array inspired.
Okay. And then you discover APL. And how quickly from discovering APL on the Stack Exchange did you go into implementing your own?
Well, we can see. So September 19, 2017 to, oh, wow, is that? Oh, no, that's a year, I guess.
Okay. Is that when you started working on it, or is that when you had first published something to GitHub where people could click on it?
Well, I I've started working on it like a bit before, but I'm pretty sure I published it pretty soon after I got like the absolute basics working. And
Okay.
at this time it was utterly horrific. It was so bodged together. There were very beautiful atrocities that you could do with it.
What's an
Unfortunately, I didn't prepare a copy of it. It would have been pretty fun to play around with. But like you could do things like assign the assignment arrow to a variable, assign a non-existing variable to a variable,
okay?
and the way assignment worked is that in like a set one, what happened is it created the variable object of a,
Mm-hmm.
which or read the variable actually, and during the left hand side of the assign, it assigned to that value that this is what should be assigned to it. So I believe that if you did like a set one and then like one set two, it might have assigned to A. Actually, no, not quite, but something like that.
Something like that. Okay.
It was utterly broken, but it somehow worked. So I guess I should mention that like the reason I made dzaim/APL is because dialog APL was pretty good, but it wasn't infinitely good. And so at this point, I was already like, as could be seen with me having made the golfing language, that didn't, if something I didn't think was good enough, I just made my own version. That's like a thing that I just do quite often. It's become rather of a problem. So, someone in chat asks why, what made me interested in implementing languages. It's pretty much just that. If I see something that isn't as how I want it to be, I will make it how I want it to be one way or another, if it's at all feasible.
So, are there things in that you implemented in Dzaima APL that are specifically, like you said, that that dialog APL was good, but it wasn't infinitely good, which kind of implies that either stuff was missing or stuff didn't work the way that you wanted it to work? Are there some um, either major differences that are like worth highlighting in your implementation of APL, or maybe not major differences, but just like certain behaviors that you really wanted that, like for instance, one of the things I'm thinking about is the scan in Dialog APL. It doesn't work the same as the one in BQN. And I
Yeah.
consider that like a pretty big flaw in my opinion. But my question to you is like, what were those things for you that you were the first things that you did in Dzaima APL that were different?
So one of the things I do differently is that a reduction on a list doesn't return the value enclosed, which is very odd considering the high rank usage where that is kind of necessary. But I didn't care much for rank agnostic code, so I just did that, and that's how dzaima/APL works. So like sum 1, 2, 3, 4 gives back just 4, 6, and not enclose 4, 6.
Okay. And
So
that's kind of similar to the difference
here's
between
di-
fold and insert in BQN, right?
what?
Is that's kind of similar to the difference between fold and insert in BQN? Like I think
Yeah,
if you do
yeah,
insert, it gives you back the box result, but if you do fold, it won't.
yeah, exactly. That's what the two different symbols are for in BQN, but I could do with one symbol. What can go wrong?
Yeah. Okay. So that was one of the things. Are there other ones, or is it's things in that kind of vein?
I don't remember scan. Okay, yeah, scan. You mentioned scan being wrong. I fixed that.
Yeah, that's
Uh,
probably one of the like I actually forget that because I program in BQN way more often than Dialog APL these days, but I forget that scan is broken sometimes, and then when I go to write some equivalent piece of code and it's not, I'm like, oh yeah, this is and it's also one of the things that like you can't really fix, right? Like um you would either have to like introduce a whole new operator and then avoid the original one, or just like make a breaking change. And yeah, it's very unfortunate.
yeah. Okay, there we go. Now, okay, seems plus scan is always. Yeah, first of concatenate reduce.
And do you have
Yeah,
other symbols like obviously these are what do you call them, staples in BQN now, but like the under modifier that Dialog APL has been talking about adding and is either going to be in 20 or 20, or they say it might be. I shouldn't speak for Dialog APL. Is that stuff that you've implemented in Dzaima APL as well? It looks like you have, although
yep.
um,
There we go. There's the under.
yeah, and I think that's the same symbol. If or has cap implemented under yet? I think they have, but
Yeah, cap does implement it
yeah.
with exactly the same glyph.
Yeah. There's something about the cap glyph set.
Oh,
I'm,
maybe not.
or maybe
Oh,
not.
right. What was it? Was it?
I do see it
It
on the
wasn't the
keyboard there.
BQN
For the
glyph.
audio listener, under in cap, potentially, at least on the keyboard, it is the delta, upside down delta with a diaresis on top of it.
Oh, yeah, right. This is cap. I can't have a left upper end of an array. And it swaps those. There we go. That's the equivalent. There we go. 1 to 300 first of iota 10 in cap.
Yeah, that's nice. Honestly, under is that's one of my takeaways from this year's Advent of Code is that under it's almost like a whole paradigm to itself, like the usefulness of it. And once you really learn all the different things you can do with it, it's hard to go back to not having it. Oh, is this a search of all the different places that you use under?
101 101 times it's used in my this year's
Yeah.
actually.
So there you go. And
Yeah.
that's only like we're on December 20th, so that's only 20
Yeah.
days.
Yeah, that's 5 unders per program
Yeah.
per day. Or well, I do have like 2 files per day on average or so.
Still, I
So
mean, whether
and
it's 50 or whether it's
yeah.
basically you can basically say on average every single solution is like maybe the first couple don't use them because they're a little bit simpler, but like you can just see on that or you scroll past it, but there was like a chunk of code where you had a bunch of pick under like one pick two. It's just such a like that's an idiom that I hadn't really used before. And now that I know about it, like when you're doing you're using under with pick, or you're using under with a mask, and you're compressing or replicating or whatever the correct terminology is. Like that's such a common pattern, and yeah, I used to only like do things under reverse and under permutations, not so much selections, and yeah, it's a very very common. So Dzaima APL has under. I'm guessing it has some other things. So I mean, what's the story from? I mean, I've heard Marshall say that at some point, I can't remember if it was on the APL Stack Exchange, he mentioned that he was going to be creating this kind of next generation APL. I'm not sure if he had a name for it yet. And then from Marshall, I've heard that you immediately like shot your hand up and said that you were interested in helping out with that. And I guess
Yep.
you're bringing up that exact correspondence.
Yep. So here is Marshall's first message at 1641, and my response. Where is my first response? I know I typed BQN wrong. Why is my first response? All right, this is Marshall, but not named Marshall because Stack Exchange. But yeah, I was fully in on working on BQN and discussing stuff basically immediately within hours.
And yeah, for our audio listeners, this is a search of Stack Exchange, and the date is it says June 5th, 2020, and so I guess that's just under 2 years after you had first published about Dzaima APL. So yeah, walk us through the story of.
Yeah.
I'm guessing you took the existing code base for Dzaima APL and reused a certain amount of that. I'll let you tell that story, and then how you ended up going from there to starting over with CBQN.
So Dzaima/BQN is entirely Dzaima/APL, but just slowly changed over time. At the mid during that, for a time there was a BQN or APL evaluation semantics, but then I wrote the compiler, and then it basically became a pretty normal BQN interpreter. It's mostly time/APL primitives, basically everything except the glyphs and like the couple different primitives and of course the compiler. But the core of it is still like the majority of the primitives are reused entirely.
Interesting. So it actually was not as much work as maybe one would expect from going
Yeah,
to quote unquote a whole new language, because I guess BQN is strongly influenced by APL.
yeah. Hmm.
Were you just trying to look
So
up the
that's
when you like pushed the first BQN from June
yeah,
5th to when you had like a
yeah,
new repo with the BQN glyphs?
yeah. Unfortunately, they're two separate repos. I cannot be bothered to figure out where is the split off commit. Actually, nope. Okay, no, there are a ton of commits. Who would have thought that there are a ton of commits on?
I love the messages
So
too.
yeah.
They're very concise. All of my messages are just like fixed a thing, added a thing, and
I've I've tried to like start doing more normal messages. The BQN has like, okay, now fix case, fix that. This was an amazing bug.
yeah, I saw you post
LCM
something about that on the APL Farm
chat
BQN
room.
Discord, saying I can't believe this bug went latent for so long. What was the
Mm-hmm.
walk people through what the bug was and how it went unfound for so long?
Can I, let's see, is this an old enough version? Actually, no, I have versions of it. So, like math.LCM 1015. LCM is 30. Makes sense. Of 10 and 15, 15. Nope, 5 isn't correct. That's the GCD. And the problem was as simple as the LCM function when it didn't match the scalar arguments. It just called into GCD. Copy paste error.
Yeah,
Very
I saw the
basic.
fix. Yeah, it was just replace
Yeah.
GCD in this one place with LCM, and I guess just
Yeah.
people.
No, nobody had used it on arrays, it would seem. It's just that simple. Even the error message was wrong.
Yeah.
Yep, calling LCM and it says GCD.
Yeah, I have to be honest. I'm trying. I know I made a YouTube video at one point where GCD was necessary, and I think I'm not sure if maybe I didn't solve it in BQN because I know in APL the superset of um, is I can't remember what the symbols are for it. Is it the logical and logical or? The dyadic versions, those. Well, no, the dyadic versions have to be those. I can't remember what the symbol is, but in Dialog APL, they have LCM and GCD. Oh no, I
No,
think
they are
it is that.
they
It's that
are
it's the
and
extension
no.
of it to non-Boolean values is when, yeah.
There we
So
go.
I can't
Yep.
remember though if I solved it in BQN, but I guess if I did, it wasn't using the a rank one array. It was probably just using scalars, which is why. Because guaranteed people make use of those functions. It's just maybe not in that pattern.
Not as common. Chat question: what compilers techniques have I learned? I basically all of the compilation techniques, everything is rolled all by myself. I don't know what to call it. It is whatever made sense to me. And it is awful, but it works, and that's been enough for me. So unfortunately, I cannot tell anyone to do something specific, but
Well, I mean, what makes you say it's awful?
mhm.
Is that just because you didn't get it out of a textbook, or are there's patterns that
Well,
you've used
it
that?
is. Let's see, where is it? This is the dzaima/BQN compiler. So, okay, there we go. This is how a top is implemented, compiling it. There's a function. Here's a string describing how it looks. Function, function, preceded by one of the assignment operators, or not operators, characters. And that is how it is implemented. It is extremely inefficient because this is a loop over the pattern, looking for the characters, normalizing characters, doing a bunch of loops. It works. It doesn't work fast.
Yeah, okay. So just for the audio listener, we're looking at this is to be clear for dzaima/BQN, not CBQN. We're looking at the predecessor in Java to CBQN,
Yeah.
and we're in a file called comp.java. And also I apologize. I never know if it's Java or Java. Apparently though, because I'm Canadian, I'm allowed to say it wrong because maybe we say it differently. But we are looking at a lot of nestedness. Like right at the code, we're looking at line 1016. There are 5 nested ifs inside each other, which
Sick.
is kind of, if you've seen certain YouTube videos, they talk about like depth or triangle, the amount of white space in between your code, and the more indented it gets, isn't necessarily definitely a sign of suboptimal style. But I could see maybe why you're saying this is not, it's not great. But it's also Java, so
Yeah.
I'm not a Java expert. I don't actually know what idiomatic. Paul in the chat saying, if it's stupid and it works, it's not stupid. Yeah, isn't there's a quote from Joe Armstrong, the creator of Erlang, who said, I think it's make it work, make it good, and then make it fast, in that order. And a lot of people, they over-index on making it look beautiful or making it fast, and when they should be just starting with making it work. I know Richard Feldman, who's the creator of the Rock language, he takes issue with that quote because he says if you just start coding from scratch and you don't think about, making it performant or making it look nice, sometimes you'll paint yourself into a corner. I tend to disagree with that. I think that like a lot of people are capable of stuff and they don't go out and, program it or do it because they think, oh, I don't know how to do this the right way. And when it comes to coding, sure, there's a maybe better ways, but like it's better to just, do it suboptimally than not do it at all, in my opinion. There's a couple more comments in the chat. The lightweightness of the CBQN implementation is a very attractive quality. Your work shows a minimalism aesthetic, as Stephen Taylor has phrased. True, and your thoughts or motivations. So I guess maybe we can talk about your transition from dzaima BQN, which is what we're looking at now, to CBQN. What's the story behind abandoning the Java? I mean, probably a part of it, as you're saying, is that it was too slow, and that's a topic we're going to get to too. Is a lot of the advent of code solutions, you'll do your initial one where you're just trying to solve it as fast as possible, then you'll go clean that up, and then a lot of the times you'll implement a underscore fast version, which is runs in milliseconds most of the times.
Microseconds.
Microseconds. So yeah, talk us through the transition from BQN to CBQN, and what the motivation was there.
Okay, first things first, a bit of a comment on that whole discussion about how to make things. My general approach is decide what is my target, like performance and whatever. Decide ahead of time, like most things, how I expect them to perform, and after that, do whatever. So here for dzaima, APL, and BQN, my goal was have it working. I didn't care about performance at all. Okay, so for dzaima BQN in particular, like this is the compiler. It runs once. The performance of it doesn't particularly matter unless you're like using bullet BQN for evaluating a bunch of numbers, which is quite inefficient. Actually, not even for that does this matter because that takes a fast path. But yeah, decide like the general architecture. I think is pretty important to get decided upon very early on. But after that, mostly anything goes. So okay, so that's that. Okay, so CBQN. The reason I made CBQN is because I thought that a C implementation or some low-level implementation should exist. Nobody had made it yet. I was getting tired of waiting, and so I made it myself. That's basically the entire story.
Wow. I mean, yeah, kudos, because now I think I don't know what the number of BQN folks is out there. I know that there's at least 30 or 40 people doing it in Avid and Code. So I imagine outside of that, there's hundreds, if not, I'm not sure it crosses the 1,000 mark, but there's definitely all the people out there are. I think basically using CBQN. I'm not sure if there's anyone that's still using the Java one, and I guess technically is the BQN that is on Marshall's site. That's a different BQN, correct? That one's
Yeah,
implemented
this
in.
is implemented in JavaScript.
And so, who is actually?
And
That's a good question. Who has written this one? Are you also responsible for this implementation?
okay, so this was originally not written by me, but at some point I got tired of it being so slow,
Mm-hmm.
which is like a pretty general pattern here. I get tired of something being bad, so I improve it. And so I changed it from being uh, like a standard while true switcher over the bytecode loop to a while true switch over bytecode thing that generates JavaScript. So that's the part here that I am responsible for, which is transpiling BQN bytecode to JavaScript, which is how this is not entirely unusably slow and just mostly unusably slow.
And was Marshall the individual that wrote the first iteration, or was it a bunch of folks, or
Yeah,
you're not sure?
that's Marshall. That's Marshall.
Interesting. Okay, so that's three. And while we're on the topic of other BQN implementations, so you have two, CBQN and dzaima BQN, which is implemented in Java. Then there's a combination of folks, Marshall, yourself, that's worked on the JavaScript one that the website uses. Are there other BQN implementations out there that you're aware of?
There are a couple others, nothing as complete though. Where is the page? Yeah, here. There is one in
Racket.
whatever arcade racket. Yeah, that's it.
Interesting.
On like the rest of them are on the level of the JavaScript implementation or like less than it, less complete than it, or like at least less performant because there are the BQN self-hosted runtime is in three parts: the compiler, R0, and R1. Uh, R1 implements like most of the non-trivial primitives on the inverse of the pervasive primitives, uh, search functions, whatever. Uh, and that builds upon R0, R0, which has like a couple more, which has more low-level operations, but still like not entirely trivial, and that's based on completely basic operations. So that's 3 layers of primitives. One can choose to implement however much of that one wants, and the JavaScript implementation implements R0 fully natively. Most of these others still use the self-hosted runtime for that. So yeah, Racket. There's Julia. There is a CBQN in C++ from a long time ago. Like most of these aren't particularly maintained 11 months ago.
Yeah, I know Asher. I have talked to him about that, and he said he worked on it for a bit, but hasn't looked at it recently. So wait to go
Yeah.
back because I did not know this about BQN that they have these 3 parts: the compiler, R0 or R naught, and R1. So when you say that you can choose to implement any set or subset of these, what exactly does that mean? Does that mean like there's a place that you can go and pull either the compiler or R naught and then only do like how do you what do you pick and choose which ones you're implementing and then stitch a interpreter together, if I've understood that
Yeah.
correctly? It
So
sounds like you can do that.
yeah. So this is R0 runtime part 0. I guess is the full name Marshall has decided on it. It requires these couple of primitives and only very basic cases like the plus needs to only work on atom arguments, and the rest for the rest of the same for the rest of the arithmetic. And like here, right tag is defined as a block of x. This is all invalid code, of course, as can be seen by the squiggles. So this is transpiled. So I don't think I have. Yeah, I don't have a transpiled copy here, but yeah, it's transpiled to valid BQN, and then like this right tag up becomes like F0 or something, and then in the implementation you can decide that right tag used, but when the compiler, so you give the compiler a list of the primitives, and in the place for right tag you just give it whatever the transpiled R naught gave you.
Interesting.
Or well,
So this is a invalid BQN source file, which is called for the
yep.
audio listener r0.bqn, and this is transpiled into valid BQN, and then this is used with your implementation of R1.
Well, okay, so this is R0. There's R1, which does a lot more stuff. Let's see where could be like, okay, where is an interesting primitive? Like less than. It's implemented as the less than symbol monadically, and dyadically it's 1 minus greater than, or no, I've got it wrong. This is less than 1 minus greater than or equal is how it's implemented dyadically. This is like the level of implementation here that this does. So yeah, so these both files are transpiled to BQN, and then from it you get out a list of the more complete primitives, and then you can pass those to the compiler, and the compiler will use them to produce bytecode that uses them.
Interesting. And
And
so for all these different implementations of Racket, Julia, Rust, etc., what have they done? They've gone and taken some
they've
component of this and
implemented
rewritten.
they've implemented these couple primitives,
I
like
see.
these.
So yeah, for the
Here
audio
they are.
listener, there's a list at the top of r0.bqn that lists out some scalar functions and some other functions. And so as long as those are implemented in your language of choice, uh, at the end of the day,
You
this
can get out a
yeah.
you can get out a full complete BQN implementation. Yeah, they are. The specific requirements are listed over here on Marshall's BQN website under the implementation
Mm-hmm.
list. It's extremely basic stuff except group. This is like the one weird thing. There's style each of group and join group
I was gonna say
required.
grouplen, if it's the same group that I'm thinking of, is actually a primitive in Jelly, um, because it's an extremely useful thing for code golfing. Like there's like problems like maximum consecutive ones that grouplen is like 90% of the solution. You just have to do a max reduction. So yeah, Dzaima's writing out some BQN code here.
Yeah, that's that. These are like the two weird ones. Uh, Marshall somehow decided that these are like the two operations that can be very well built upon to like make everything not entirely unusably slow. I was there amend? I guess there's not at some point. I feel like that there was an amend requirement. I guess there isn't anymore. But yeah, very basic stuff over here. And then from that you can get out a BQN interpreter with all the primitives, but it's not gonna be fast.
Interesting. This has been a very interesting digression. Yeah, we'll throw links, especially for the audio listener. If you're curious of looking at this source code, I'll make sure to grab some links and throw them in the show notes and in the description of the YouTube video. Although for the folks watching right now, you've already gotten a live look at this stuff. So, I mean, hopping back to CBQN, you were waiting for a low-level implementation that was more performant. You got tired of waiting, so you implemented one yourself, and then you chose C as your language of choice. Yeah, how did that go? How long did it take? Was it a lot more difficult doing a low-level implementation versus your previous implementation in Java for both APL and BQN?
Mm. So CBQN is my first non-trivial C project. Actually, no. Well, okay, yeah, it is my first non-trivial low-level project, but I've used C and C++ for, well, I guess only C++ for programming Olympiads. That's like another thing I completely forgot to mention. Across like the entire span of when when I was in school, uh, I was going to programming Olympiads in parallel. I have no clue. I do not remember how I learned C++ enough for that. I guess just living off of cppreference.com
Yeah.
or whatever. So yeah, that is, I guess, where I learned C and C++ from. I, I mean, I've used it like for a couple tiny things every now and then, but nothing anywhere near as non-trivial. I'm pretty sure it's my first C project with more than one source file.
The
But
programming
yeah,
Olympiads are those things that were like local, or did you? Because I know that the ACM ICPC, which got mentioned earlier, that's like a global thing that I guess depending on the university you go to might not have an active team. But like, was it like local things that you were doing, or was this stuff that like you competed at the I don't know what you call it, elite global
so
level?
mostly locally, but I do have one bronze in IOI.
Okay. That's super cool, and definitely ties into the story, yeah, of how you ended up on these top 100 Advent of Code leaderboards, because that's definitely the same kind of skill set. Um,
Well, not really, but yeah, sure.
Well, I guess
It's a
yes.
lot. Those are a lot more algorithm focused, coming up with non-trivial algorithms, which I don't like actually. I still participated. I didn't prepare much,
Mm.
so
Yeah, I guess uh, in those like Olympiad and ICPC contests, maybe the first couple you can get away with by just doing the greedy or the brute force solution, but then very quickly, yeah, you need to know different types of searching and graph algorithms and stuff like that. Whereas,
yeah.
it,
Oh,
at least for this year in Advent of Code, well, I mean, I've only read the problems up to day 14, but like I think all but one of them you can kind of just brute force. There was, I guess, a second one, but like for the most part, you can get pretty far with just like doing the greedy algorithm, and then maybe you need one tiny trick for a couple problems. But
yeah. I I do not like graph algorithms.
well, I guess yeah, we'll get to that in a second because definitely yeah, I want to chat about Advent of Code. But we'll stay on CBQN for a second. So it's your first major, you said, C project. You had done C++ and a little bit of C before. Anything worth highlighting about your experience? Like, do you regret the choice of C? Was it's actually not as bad, or the lack of guardrails makes it easier to move faster in C compared to like a language like Rust, where famously you have to fight with the borrow checker. What was your experience, implementing CBQN?
It went basically how I expected it to go. I'm pretty sure. It all of the manual reference counting stuff and whatever that didn't cause me that many issues. I'm pretty sure this is a long time ago. But yeah, I'm pretty sure it basic was pretty acceptable, normal stuff. Every hmm, yeah,
So it wasn't too difficult, basically as expected.
yeah, yeah. They basically went exactly how I expected it to go. I met so starting out, I had this. Okay, so another thing that started me making CBQN is because I came up with this idea of how to represent arrays and specifically the shapes of arrays that I think is like just amazing in how simple it makes some things. And so, okay, so that I think is probably worth touching on
I was
a
gonna say,
bit.
yeah. Can you walk us through
So,
that?
so CBQN struct R array has two fields, a size field of the product of the shape and a pointer to the shape itself. So and and of course, like there's ranks stored in the first header of the object. So the first 8 bytes contain ref count, memory manager info, some other metadata, and 8 bits for the rank. So there we have the rank. We have the shape pointer. That would be enough, albeit it would be quite inefficient to have a separate allocation for the shape of every single array, so which would mean two different array objects, two different objects for each array.
And this is
So what I
just to
do
be
instead,
clear, just for the shape. This isn't storing any of the contents of an array.
yeah, this is just the shape.
So it's a
So
product
what
of
I
the
do,
of the values in the shape, and then the shape itself has a pointer.
yeah, yeah. So the product, so it happens for rank one. This shape pointer points to the array shape product field instead of a separate allocation. And for higher ranks, it points into separate memory allocation, but for rank one, it points into the array object itself,
Mm-hmm.
which means that I can very quickly get the product of the shape, which is actually what quite a bit of code cares about, and it doesn't need the full shape. You still have the full shape. Both of these are branchless. The only cost really is that freeing the object has to branch on whether it's rank less than or equal to 1 or greater than or equal to 2.
Okay, that makes sense.
So that's like the only cost. Everything else works out wonderfully. So this is like the thing that I came up with that I thought was very neat and which I wanted to put into an array language implementation. And so I did.
And so the main difference here is, at least, I haven't stared at too many other implementations, but typically I would assume that a lot of implementations don't store this product as a separate parameter. And they definitely don't do this like indirection of, well, the contents could be in the shape if it's rank 1, otherwise different. Usually you'll just have like a shape, vector or pointer, and then you'll have the same thing for the values. And then whenever you want the product or to check, the size, you have to do that computation. So you're saving yourself some work here. And probably in the most common case, which is probably rank 1 vectors, you aren't losing too much compared to that. It's only in the case where you've got rank higher than 1 that you're going to end up with
a separate allocation.
Yeah.
But like even then, when you have, say, a rank to array, this shape pointer points inside the shape object, and that object is reference counted too, which means that multiple arrays can share the same shape. And that's actually what in most cases you get. Like if you add 1 to a shape 1020 matrix, 10 by 20, like the shape object can be reused. All that happens is a reference count increment. You don't even have to copy the shape. It works out pretty well, even for high rank arrays.
Right. So you're saying that for a lot of operations, like basically all of the scalar operations, you are in the case where you're gonna have, quote unquote, multiple objects being created, but because they're scalar, they're not reshaping the data in any way. And even some permutations maintain the shape, right? If you're doing a row-wise reverse, your shape is still the same at the end of the day. You're not going to have to end up copying these shape objects over and over again. If I understood that correctly.
Yeah, something like that.
Interesting. Okay, so that's a slightly different implementation for the shape of these arrays. And what has gone into, because one of the things, I think the episode isn't out. If you're watching this, there'll be a arraycast that launches in the next, I think, 12 hours or something like that. And we had both Kai Schmidt of Weewa and John Ernest on, and we were talking a bit about Advent of Code. And at some point, there was a comment by Kai saying that like the performance that folks are getting out of CBQN is like a completely different stratosphere than compared to Kai's Weewa implementation. So yeah, what is and maybe we can segue into a little bit of Advent of Code. What are the techniques that you've used that has made it so fast, basically? And in some of the Advent of Code solutions, you've done some like incredible quote unquote like underscore fast solutions that just blows some of the naive stuff out of the water. So, we're kind of into the last third of this podcast, and I definitely want to talk to you about, if people are programming in these array languages, I want to highlight like some of the performance techniques that you seem to be like an expert in, because I think that's something that like not a lot of people are aware of that you can get like just crazy fast times out of these vectorized interpreters?
Where to start? Singeli. Someone in chat answered my question. Thank you. So, uh, indeed, most of the non-trivial stuff is implemented in Singeli. Uh, let's say dyadic arithmetic. This is a file of 200 lines of 200 lines implementing addition, multiplication, subtraction, minimum, maximum. What else? Or and minimum max. I said already. Yeah, those. But like all of them are implemented for a bunch of type combinations. Addition, like okay, so CBQN has 8 main different types. If I could type bit Boolean arrays, 8-bit integers, 16-bit, 32-bit, and 64-bit floats. 32-bit integers, 64-bit floats. 8, 16, and 32-bit characters, and then of course the generic heterogeneous arrays. So all of the arithmetic needs to handle all of the different combinations, but all of them would be a bit overboard. So like here are listed all of the different cases that are actually implemented, like minimum for 8-bit, 8-bit to 8-bit, 16-bit, all 32-bit. Minimum is quite boring, I suppose. This is for scalar array. There are separate ones for array, like when both arguments are arrays. And yeah, there are a bunch of these cases listed, like 16-bit. One argument is 16-bit, the other is 8-bit, and the result is 16-bit. That's a separate case. And yeah, they are all of them are generated by this file, which that is 200 lines, which implement all of the overflow checking. And like okay, so this is the most complicated thing. Actually, no, I guess not. Everything is complicated. There's a bunch of code for everything. But yeah, so basically, Singeli allows very easily specializing over the different element types, abstracting away some of the architecture-specific stuff. And this has been just like a bunch of effort by me and Marshall. I don't know, perhaps Marshall has by now even put in more effort than me into this. For like the last couple of months, I haven't done that much work on CBQN actually, while Marshall has kept on doing stuff. And like one of the things Marshall has been working on is improving the accuracy of logarithms and exponentials. Like currently in CBQN, if I do what based on logarithm of 1,000, it gives 2.9999999, which is not particularly good if you want to floor it. But Marshall has brought in the core math library, and that gives us a nice 3. This is actually a performance regression currently, so we'll see how that goes. This is not in mainline CBQN currently. That was, I don't know how I arrived at that, but yeah.
And so how does, I mean, there was a whole episode on ArrayCast, and also too, we've talked on Tacit Talk as well when we had Marshall on about Singeli. How does this tie into the compiler R0 and R1 stuff? Like if I go in and implement the scalar operations in my language of choice, am I now missing out on all those Singeli work because I've basically stolen, like we're talking about the scalar operations here. Uh, when you go and implement your own, I imagine you're no longer using the Singeli work, or is my understanding of that incorrect? You still get that somehow.
Yeah, Singeli is entirely an implementation side of thing. It's entirely within CBQN. You could theoretically take some parts of it and put it into your own language, but your own implementation, but that's entirely separate from the self-hosted runtimes. The Singeli implementations, or like even the native implementations without Singeli, they all primarily just replace the self-hosted stuff
I see.
instead of like participating in it.
Interesting. Okay, and so yeah, maybe we can at this point transition to some of the advent of code solutions, and you can walk folks through patterns and your thought process. I mean, one of them, and at this point, we should say, I mean, on on the ArrayCast episode, we decided we didn't want to spoil solutions for folks that were still working through it. We are not going to take that track here. We are definitely going to spoil solutions. So if you no longer want to get advent of code for some of the solutions up to day 20, you might want to pause this and come back once you've solved them. But one of the solutions that, I mean, I've taken a look at, I think, most of your solutions, but one of them that really stood out to me, and I think a couple of them used this trick, was the day that had the edges of the garden plots. I can't remember if that was day 12. It might have been.
Garden plots.
I think it was 12. Yeah. Yeah, exactly. So you're given a grid of letters where the contiguous or adjacent letters represent a plot. And for part A, I think you need to measure the perimeter, which is a simpler problem. But then for part B, you have to measure the number of edges. And I think I tried 3 different solutions until I found one that worked. And my solution ended up basically getting windows, 2x2 windows, and you could determine every corner of a garden plot with a certain number of patterns. If you think about like concave or convex corners, they're all identifiable by a certain amount. When I looked at your solution, you had basically done a bunch of shifting. Yeah, on line 5, you've got left shift, right shift, and then row-wise versions of these. I think you might want to, if you're able to zoom in a couple more, just so folks.
Can I zoom in, please? Thank you.
Oh, there we go. Yeah, walk us through. And I think that day 12 is the day that you solved it in like 8 minutes or something. And this is one of the days, correct, right? That you ended up on the leaderboard?
I believe so, yeah.
Yeah, day 12 was 86, or score was 86th. Rank was 15.
15.
Yeah, that's nuts. So yeah, walk us through this, and hopefully we'll be able to pick up on this kind of pattern that is completely beyond what I came up with.
That's fine. So indeed, I have the shifts. They are. Does it matter here? Okay, yeah, it does matter here. The order is shift right, shift down, shift left, and shift up. That's 90-degree clockwise rotation. And then I compare the shifted versions with the original, which basically gives for each direction whether in that direction there are different characters in the current position.
Mm-hmm.
So these are the 4 matrices here. I can make them more pretty. There we go. I mean, there is not much information here, I guess. But yeah, so now that we have, so the main idea is for part 1, detecting. Okay, so what was part 1? Part 1 was counting. Oh yeah, the
The
perimeters.
perimeter, yeah.
So by getting the compared version of the original and shifted, so there are the different differences, and how does it
I
work?
guess I guess I could see that anytime you have a difference where they're not equal, that is 1 unit of the perimeter.
Yeah, so this finds that characters that are on the border for
Right.
each separate edge,
Right.
for each separate direction, I suppose. So, and after that, oh yeah, right, there's, wait, this is just for finding the region. So these comparisons are actually only used for the kind of flood fill thing that expands each region to, okay, yeah, I suppose this is like the main part. So I start out with a different number for each character. And then the goal here is to, instead of, where is the input? There's the input. Instead of a different number for each character, have a different number for each region.
Mm-hmm.
So like the R region. And the complicated thing is that you can have multiple disjoint regions with the same character. So the idea that I went with is that within a given region, the goal is to get to propagate the minimum number to that entire region. So over here we have this 4 by 2 by 2i region, which would be what over here, 4, 5, 14, 15. And the goal would be to get 4 to be over all of these 4 cells.
Okay, that makes sense.
And so the way to achieve that is shift around the numbers. You shift the number with each of the shifts. You shift the number matrix around and mask it by whether the characters were equal here. So like the 4 would be shifted right to over here, and it would stay there, but it wouldn't. But in the copy that shifted left to this 3, it would be masked out by the different mask, wherever that is. And so that's how it ends up at. Nope, we don't want this yet. Oh wait, no, I take the maximum, not minimum. Anyway, same thing.
Same idea,
So
though.
the
I
15,
was looking at the maximum glyph and wondering if that was the case, but exact same idea. Just replace min and max.
yeah. And so we've got the 15 propagated to all of them. It's flood fill, but instead of with physical borders, the borders are kind of internal in between the different cells.
And
I
does
suppose you could also do it like that.
is the order
Expand.
that you shift these, does that matter? Because in my head I'm thinking that if you do the shifting in maxing, if it doesn't propagate the information correctly, like you'll end up with not a fully flooded like area. So is that taken into account, or am I missing something about this that's not actually an issue?
This is done in a fixed point loop. So it's done until it
Oh,
stops.
interesting.
Until it
That's
stops
like a helper
affecting
function
anything.
that you have implemented.
Yeah, in my utils.bqn file in my AoC repo.
Interesting. Okay, so that's the trick for it's gonna iterate until it's stable and that there's no
Yeah.
more changes making place. Okay.
So, and then after that, classify under D shape, which nicely maps the different numbers we have. We took the maximum like 15, but 15 is a large number. So the classify brings all of the numbers down to the lowest,
Mm-hmm.
such that they are all sequential, which is better because no gaps for group or whatever follows.
That's a cute trick that I've never seen before. Although classify is it's not a primitive that I reach for super often.
Yeah. Classify, like anytime you have group, other than like splitting, using group for splitting, classify is extremely common.
Yeah, I guess that's true. Classify uh, before group is actually an
Yeah.
idiom that I've used quite a bit.
And actually, that is essentially what's happening here. Like the classify over here is actually just directly going into the left argument of group, except with these shapes because the BQN is slow in this case.
Interesting.
So, so yeah, actually the, the there is a pretty big difference actually between my this optimized solution and the original. In the original, I actually don't do this fancy flood filling with maximum and shifts.
Mm-hmm.
Well, do I still use shifts? No, I don't. I do a classical, what is it, breadth first search over all of the different possible positions because I'm solving this for solve speed, so I just write whatever comes first to mind.
Mm-hmm.
And so yeah, over here in my original, this will give a mask for each separate region instead of all of them in the same instead of all of them in the same array. So like here's the 2 by 2 little square, a separate mask for each region. This is a lot easier to work with. So now that we have so with this perimeter, I guess I already went over how to calculate the perimeter. It's just comparing all of the different shifts and finding out which of them are on the edge. So, oh, this doesn't give the mass. I want the mass. And perhaps I should make it pretty. There we go. So, like this blob over here, here are the edges that are on the right. Here are the edges that are on the left, on the top and at the bottom. And then summing all of these together gives the perimeter.
Yeah, that's really nice.
And then on part 2, for getting the number of edges, it works out very beautifully. So with the separate mask per direction, essentially what you want to do is convert each vertical line or horizontal, I guess, in the horizontal directions each line into just one character. And this is again just shift and compare. So here is the long edge of this blob. I guess that's a garden in the text. I'm calling them blobs. And the goal is to convert it to just one character instead of 5. And I think this is extremely overkill the way I've written it here, but it does the same thing. So, yep. So here, this vertical line has been replaced with just the top character.
And what's the
Here,
technique that it's collapsing every edge into a single character? Like, what is
it's again just a shift and a compare and AND negate, I guess. If we have zeros, ones, zeros,
Oh yeah.
you shift them by 1. And yeah, X and negate shift X. And that gives you the first one of every sequence of 1.
Yeah, it's honestly like a modified differ, if you're familiar, or if listeners are familiar with the differ function from Q, which is a not equal to 2 reduction, 2y's reduction. So you take adjacent elements and you look if they're not equal to. But in this case, you wanna mask out one of the 2 of them in order so that you collapse it down into one thing, not 2 things. That is super a super neat trick. I would have never thought of that. Was that like immediately obvious to you because I don't know, you just are thinking in arrays all the time, or had you seen this kind of pattern before, or this seems like a yeah, it seems like a non-obvious thing to me.
This pattern of X and negate shift X, that's actually what's happening in both part 1 and part 2. Like this is shift and shift negate, and this is and shift negate, but 90 degrees rotated, which is, I think, really nice how both going from the blob to edges and identification of a single edge is the same operation. It doesn't look the same because I suppose there is the extra. Actually, I don't know. I haven't. But
Yeah,
semantically, I think of it as the same operation. It's like it's finding the first occurrence vertically and then horizontally.
For the audio listener via podcast, I would highly recommend, at least for the last 20 minutes of this podcast episode, you check out the YouTube video, because Dzaima's been showing basically, it's not even pretty printing, it's just the default printing of rank 2 arrays in BQN. So it's a lot easier probably to follow if you can see the visualizations of what's being talked through right now. Yeah, that is super, super nice.
Yeah, for the fast one, I do the thing that you said of matching pattern, except I do it with shift because, of course, shifts are faster than most things, really. What are you gonna say?
Oh no, I wasn't gonna say. But speaking of shifts being faster, maybe as like kind of a final question or topic. I know that you've run some profiling where it shows the time execution of each of the solutions. Do you have a way of knowing the like for instance, that a shift is faster than others. So yeah, we're running through the solutions now, which is crazy how that was like a couple seconds for all 20 solutions so far. And some of them are, yeah, just blazingly fast.
Why is there one failing test? Oh, because I just added shows in it.
Oh yeah,
Fail.
and then that breaks it. So
Just testing all of them is 700 milliseconds. That was for this perf thing. It actually repeats them for like a tenth of a second.
oh wow. So yeah, I mean, how is are you just measuring the overall solution time and then using your knowledge of primitive speed, or is there some way where you get like an output? Because I've seen in the Discord chats like, oh, this primitive is taking or whatever. I've shaved off this much. Is that just because like from solution to solution people have removed something and then it got faster, or is there some way to like do a primitive analysis of what's taking the most amount of time? Because it's you seem to have some tricks up your sleeves, or maybe it's all just like knowledge of knowing what's fast and what's not from having been the one that implemented CBQN.
I think it's primarily that I just know what should be fast, but it still helps double checking because there have been a couple of times where I've done things that I hoped would be fast but weren't. Namely, I had the rotate function that I was repeating a negative number of times, which worked, which is wonderful, but it was slow. And then in another day, selecting rows of a matrix under selection of rows of matrices is currently slow in CBQN. But yeah, besides knowledge, there is in CBQN there is profile, which I've just ran over this day 12 solution, and it shows how much time was taken per line. Technically, there is information about the performance per character or, well, byte code, but I don't have a way of nicely pre, pre, pretty printing that in a text format, so I just currently show it by line, and here we can see that in this day 12 solution, most of the time is taken in the flood fill. The actual part 1 and part 2 solving is a tiny fraction of the time. So
Interesting. What happens if you split that block into multiple lines? Does it still treat it as a single line?
it does separate them.
Wow.
Actually, I guess I can do a bit more
This is so this is exactly the
separation.
kind of thing that I was wondering if yeah, this is super neat. All right,
And
link
then
in the description and show notes to this utility, a profiling function that gives you byline, and it represents the number of times something is called or the amount of time spent on the line.
it's a sampling, so it's really just a percentage of runtime, I guess.
Okay.
Except I show it as sample count, so it's like by default sample is like 5,000 samples per second or something like that, and like some lines here are 500 of those for however long it samples, so like 2,000 samples, and like this one line being 500 samples, so it takes a quarter of the time. It probably would make more sense to show it as a percentage, but it doesn't. Maybe I should make it show percentage. Probably I should make it show percentage, but currently it doesn't.
It's very
And
cool.
the other thing is perf record on Linux, at least. Other operating systems probably have some equivalent, but this just This is like standard perf on Linux, which just shows per function, per C function, the runtime. So here we can see that 27% of the time is spent in maximum of 16-bit integers, and then some more time in multiplication, and so on. If there is like cond underscore C1 or C2 at the top, that basically tells me that something is running in the self-hosted runtime, and the self-hosted runtime DR1 is quite slow compared to CBQN, and that usually means that something should be replaced with something different, basically, for the time being, while CBQN still doesn't implement them natively. And for perf report, I just showed the TUI that comes with it. I have my own GUI for it. Why is there no source mapping? Who knows? Oh, I'm not using the correct copy of CBQN. If I use the proper one, so this is like the second level. Besides profiling, I just look at the symbols, like group to 6%. That's probably not the significant thing taking time, but like maximum here. It's all SIMD, of course. We can see this is the Singeli code,
Mm-hmm.
the C code that Singeli generated. We have the load, maximum, whatever. Here's masking 16-bit integers by packed with booleans. It's less trivial, but it's still pretty fast. They're basically the same. I think they have the same amount of calls in the code. So yeah, it's this. I look at perf report and profiling, and of course knowledge of what I think should be performant.
And I mean these are amazing resources. The GP, I think you said it was like a wrapper tool that you built. Is that something people have access to, or is it?
Yeah, it's GitHub dzaima /grr.
Amazing.
It's for, besides for perf, it also can be a GUI for GDB and RR. RR being a record replacing that is absolutely invaluable for debugging. Like, okay, why is that not? Do I need to run this? I restarted my computer. I don't think I've set everything up. Nope. Well, this doesn't work. That's unfortunate.
But typically it does.
Typically, yeah. So yeah, anyway, that's that's sad. I wanted to show that.
Awesome. Well, these links and that walkthrough were super awesome. I'll make sure that I link all of these profiling tools and techniques in the GitHub repo in the show notes and in the YouTube description. Any final things you want to plug or say just at the end of this? I know you work on CBQN and you've been doing the Advent of Code. Yeah, any last things or things you want to plug or things you want to tell the BQN community or array language programmers at large before we sign off?
bqnlsp. I don't know if you're even aware of it.
Uh,
Recently, I added quite a bit to it. So like I can hover over a variable and it highlights all of the other occurrences of the variable, which is very useful for trying to make sense of some random code of other people sharing their AoC solutions with all the single letter variables. So I can go easily to all of the variables. I can even rename them. That's something that I added like a couple weeks ago.
And is this is something that ships with CBQN now, or is this you have to?
No, this is a separate project for made by Dedeker.
Yeah, I did. Someone
This is
actually mentioned that in my BQN format slash tooling live stream, someone dropped
that
this in
was
the
me.
chat. Yeah. And so I took
Actually,
a look at
actually,
it. So how do people use this if they're on, whether they're using, NeoVim or they're using VS Code? Is it usable everywhere, or is it's a?
it's a it's an it's an LSP server. So if your editor has an LSP client, you can just plug it in and it will work, editor agnostic. So like this is Sublime Text. I believe I have it set up in Helix. Will it tell me that this is an error? Nope. I suppose everything is broken. Cool.
Does it?
I did have it working in Helix.
Yeah, does this do things? One of the missing things right now, although this might not be supported yet, is now that I have like a suite of libraries that I've been heavily using in Advent of Code. Um, right now, there's no like go-to implementation from a different source file. Does the BQN
Yeah,
LSP deal with that, or is that's on the to-do list in the future?
that is on the to-do list. It is indeed something that I've wanted. It would be quite cool that I could go to this underscore fx underscore, but no, it just goes to the declaration of the variable at the file.
Yeah.
And but like looking at the bytecode, this is just a constant load, system value, function call, assignment. There's a bunch of stuff that you'd have to, because like the way my my bqnlsp changes work, they operate on the bytecode, and the bytecode is not a particularly good level at which to pattern match
Mm-hmm.
this entire import. But yeah, it's something that I have wanted a good number of times. Maybe at some point I'll look into it, but so far I have not.
Yeah, it's that would be useful, and it's also I should look into the LSP project more because currently the methodology that I'm using for formatting is basically just pattern matching and splitting, which will only get you so far. And an LSP is actually the best thing, or to use some kind of tree sitter stuff, which also works with
This
LSPs.
pre-sitter and LSP are entirely separate. You could use tree sitter. What you really don't need is just some parser. Doesn't have to be tree sitter. Tree sitter has like the benefit of being very fast if you have a multi-megabyte file and change one character. Otherwise, its like main benefit is just that it is somewhat universal.
Mm.
You don't you could you just for like formatting for proper formatting you would just need a beacon parser. It doesn't LSP wouldn't really play a part here
Okay,
in that.
that's good to know.
But like the bytecode, there's this fun thing where the byte where using the bytecode is somewhat problematic because this X, like the way headers are implemented internally is that like the header becomes just an assignment. Like this is approximately how the header compiles. Instead of that, it becomes an assignment. And there's this funky thing where like there is this load of the variable X here, but it doesn't appear anywhere. So the BQN compiler currently just source maps it to whatever comes before it, I guess. So there's this weird highlighting where I have hover over X and it highlights the first variable in the header. So this is like not perfect, but it works well enough.
Yeah. Well, good to know that we've got another thing to put on our radar for folks that are interested in BQN. I think with that, then, though, I'll just say thank you so much for coming on. It's been awesome chatting about not just BQN and Advent of Code, but going all the way back to your first language that I didn't even know about, SOGL, and dzaima APL and dzaima BQN. And I'll, I guess, wish you luck with the remaining 5 days of Advent of Code. And hopefully you'll be able to increase your top 100s from, I think, what was it, 4 to 5. Super impressive that you're able to get on those leaderboards, and we'll have to do this again sometime. Maybe when there's some future additions to BQN, even though those don't happen very often compared to languages like WeOA, which is adding stuff all the time. And I guess there was one question that I hadn't answered till now from Mjolnir's Revenge, which is, do I have a fake background or not, or is that my apartment? This is definitely a Google provided virtual background. I don't have a fireplace behind me right now. But anyways, thank you so much, dzaima. And like I said, good luck with the rest of Advent of Code, and we'll do this sometime in the future.
Yeah, sure.
Awesome. Have a great day, everyone, and thanks for tuning in.